Hello, everyone. Today we're going to be continuing our conversation about nomenclature by looking at alkenes and alkynes. So when we're looking at these species, what we're going to do is we're going to start with our naming rules for alkenes and expand them to systems with double and triple bonds, namely alkenes and alkynes. So to do so, you need to be first fairly familiar with our pre-existing rules. However, we're going to take those and add a couple of very important exceptions. So first of all is that we're going to use a slightly different root name. So our root name is going to derive from the alkane of equivalent length. So in each of these cases, I have a 4-carbon long chain. So we'll continuously use that bute prefix or that bute root name. However, the suffix is going to change to reflect the type of molecule. So alkanes end in an ane. So not too surprisingly, alkenes will end with an "ene" suffix. So butane becomes butene. That E is doing a lot of work. Then if we go to a triple bond, we now become an alkyne. So it now ends with an "ine" suffix. So we now have butyne. So again, butane for all single bonds, butene for an alkene, and butyne for that triple bond. So this is pretty easy when we have only one single main chain. However, all of the difficulties we encounter really kind of play into role when we start worrying about system with branched alkanes or cyclic groups. So if I have to start worrying about these extra window dressing, the biggest thing I need to note is that the root name will be derived from the longest continuous carbon chain that contains the entire double or triple bond. So for example, if we're looking at our first species, our longest carbon chain is 1, 2, 3, 4, 5, 6, but it only contains half of that bond. So as a result, I'm going to have to make sure that I'm using the longest chain that contains that entire double or triple bond. So we're going to go ahead and start here and then work our way. So 1, 2, 3, 4, 5. So this is going to be my root name. So it's going to be a pentene. Similarly here, I have a 1, 2, 3, 4, 5 carbon long chain. So that's a pentane. But even though it's smaller, I'm going to give the benefit of the doubt for the smaller cyclic cyclobutene. And here in this third case, I have a 4-carbon long butyne, which will get priority over the larger cyclohexane. So again, priority is going to go to the alkene and or the alkyne. Now from here, as usual, I have to worry about identifying where that bond takes place. So let's start by looking at carbon chains. So for our 2 carbon chain cases, we're going to try and assign the numbering so that we minimize the number, the locator number of the first carbon-carbon double or triple bond that we encounter. Now, when we do this, we're then going to assign the lower of the 2 locator numbers to the bond, and we're going to insert it before that "ene" or "ine" suffix. So let's go ahead and start by looking at this pentene. So I could start the numbering here near that that double bond or further away. If I start here, I get to assign that 1 number. And here, I wouldn't get to assign a number till 1, 2, 3, 4. So 1 pentene will pent1ene will have the benefit of the doubt. So that gets our name as opposed to pentforene. Then we can apply the same principle to our butyne. This time, however, we have a little bit more freedom. If I start on this end, it's 1, 2. But if I start on the other end, again, starting here, because this is where the carbon chain starts, 1, 2. So either way, I have a but2-ine. Then we can take the prefixes from IUPAC and add them before the root name to identify the substituents and their correct locations. So again, here I have an ethyl substituent coming off that 3 position of my pentene. So I would have 3-ethyl pent1-ene. And similarly on the butyne, here I could assign the 1 position here or here to to still obtain that 2 position on the alkyne. So I'm going to minimize that number by making this 1 cyclohexyl but 2-ine. Now, one of the things to make note of is in recent years, IUPAC has changed their rules of how to name these species. And it used to be that you'd place the identifying position number before the root name instead of the ene or ine suffix. So in that case, ethylpentene would be 2-ethyl 1-pentene, designating that alkene is at the 1 position. And similarly, the cyclohexylbutyne would be 1 cyclohexyl 2-butyne. Again, these older names sound a little bit better, but they have a little bit less precision of telling you exactly what that number applies to. And when you're dealing with complicated systems with multiple prefixes and suffixes, this is a lot more precise. So we can also take these rules and apply them to systems that contain a cycloalkene or an alkyne. So in other words, where that double or triple bond is part of a ring. In this case, that double or triple bond will always receive a C1 designation. But note that we have 2 positions where I could apply that C1. So we're going to choose the C1 such that the numbering of the next substituent should be minimized, keeping in mind that we're going to always keep the priority will always go to giving the other half of that double bond the 2 designation. So for example, if I'm looking at cyclobutene, I know that the 1 position will go either to here or here. But if I go, if I start on the left-hand corner and go clockwise, I put my alkyl group on 1, 2, 3. However, if I start at top and work my way left, it's 1, 2, 3, 4. So the priority will be putting that 1 position on that left carbon. Now, if we look at the cycloheptene, this is an easier case because after the double bond, my next substituent is a nitro group. So I'm going to want to put that nitro group on the 1 carbon. So I'll go ahead and put that 1 carbon right there. Now I'm going to add the prefixes for the other substituents to identify their positions and locations. However, keeping in mind that because the alkene, the double or triple bond always gets the 1 designation, it typically will be dropped. So we will not need to number the alkene or alkyne unless it occurs at some other position for a more complicated system. So in this case, my cyclobutene, this stays intact, and I just need to identify my alkyl chain, which is 1, 2, 3, 4, 5 carbons long. So it's going to be a pentyl group located at the 3 position. So I have 3-pentyl cyclobutene. Now for my cycloheptene, we know we've got 2 nitro groups. 1 occurs at the 1 position, the other occurs at the 1, 2, 3, 4. So I have 1,4-dinitro cycloheptene. Now, what do we do if I have a molecule that contains multiple double or triple bonds? Well, then I need to slightly modify my rules. So I'm going to make sure that my root name identifies the chain that contains the most double or triple bonds. So now I want to make sure I include all those double or triple bonds in the system, no matter what. So I still end up with a pentene on this case. Now, for the molecule down below, we have a cyclohexane with a alkene present. So cyclohexene will form my root name. Now, as always, I need to establish the numbering system. So again, we're going to try and put that first double or triple bond to be encountered the earliest. So with cyclopentene, it could start at either position, at either end, because either way, I get a 1 position. Similarly, on the cyclohexene, I can put the 1 position on either case. So what we're then going to try and do is then minimize when we hit the next substituent. With if you have 2 or 3 groups, you're always going to try and minimize the number of the next double or triple bond by preference. So in this case, because we only have one set, this gives us a nice simple numbering system. So with the cyclohexene, we are going to always go clockwise around. And as a result, we'll start at this one position. Then I'm going to put a locator number for each of the double or triple bonds with the using the lowest locator number for each bond. And this would be one of those cases where we will go ahead and use the designate the one position on a cyclo group just for essentially clarity. So our pentene becomes 1, 2, 3, 4 pentene. And our cyclohexene becomes cyclohex 1, 2, 3. So 1, 3 hexene. Now we need to modify that suffix using a multiplying prefix to designate exactly how many double or triple bonds I have. So for my pentene case, I have 2 bonds. So this becomes pentdiene. And for the cyclohexene case, this becomes cyclohexdiene. Again, designating I've got two alkenes and exactly where each double bond is located. Then, as usual, I can finish with the correct prefixes to designate any substituents. So for pentene, I have a ethyl group. So this becomes our 2-ethyl pent 1,4-diene. And so for our cyclohexadiene, I have a methoxy group at the 2 position. So I get 2-methoxy cyclohex 1,3-diene. Now, this would be the case if I only have double or only have triple bonds. But what do I do when I have a case that contains both double and triple bonds? Well, in this case, this is called an anion. Because we are so clever, we combine ene with ine with one constant suffix. So first, we're going to try and establish the root name, same general rules. Longest chain or ring that contains as many double or triple bonds as we can. And now the biggest thing is we're going to use a suffix of anion. So in this top case, I have a 1, 2, 3, 4, 5, 6 long carbon chain. So I have a hexanion. And for the ring on bottom, we have an 8-membered ring. So this would be a cyclooctanine. Now we need to establish our numbering system to minimize the numbering for each successive group. And then if there is a tie, the priority will always go to giving the double bond the lower numbering. So for the cyclohexanine, I start with the 1 position. So this means I will start with the alkyne. So that gets my 1 designation. Now for the cyclohexene, I can kind of start anywhere. I could start on the double or triple bond. So I'm going to start by putting that 1 position on one of the double bonds. Now what I need, and now we need to minimize the next locator. So I could go 1, 2, 3, or 1, 2, 3, 4. So if I have to choose with an alkene at 3 or an alkyne at 4, I'll choose the alkene at 3, and this means I'll be counting clockwise. Now I need to go ahead and add those locator numbers to the names. And I'm going to add each of those locator names before the corresponding N or ine suffix. So the alkenes go before the double bonds go before the N, and the triple bonds go before the ine. So if I'm counting the hexanine, it's the triple bonds at the 1 position, and 1, 2, 3, 4. The double bond is at the 4 position. So this becomes hex 4N1-ine. These are not easy numbers, easy names to say, but they are very precise. Similarly, for this cyclooctanine, I've got 2 alkenes at the 1 and 3 position, and then I have that triple bond at the 1, 2, or at the 4, 5, 6 position. So I have cyclooct 1,3N 6-ine, clearly designating all of the positions. Now I need to go ahead and account for any multiplying prefixes. So for the hexanine, I have one alkene and one alkyne, so the name stays. But for the cyclooctanine, I have 2 double bonds, so this means I'm going to use a di prefix for this name. So this becomes cyclooct 1,3-diene 6-ine for the 1-alkyne. So, as you notice, the naming schemes slowly develop and build on each other. Now, let's try and apply this to some more elaborate systems, specifically ones with a little bit more grease, trying to figure out where we start. So let's go ahead and start with the species on the left. We're going to start with the 6-membered ring because this is going to be our longest carbon chain, and it contains 2 alkenes. So this means I start with the cyclohexene. And again, trying to reduce numbering, 1, 2, 3, 1, 2, 3. Either way, I got the cyclohex 1,3-diene. Now, I have to worry about these bromo groups as prefixes. So here, I could put the first bromo at the 4 position or the first one at the 1. So I'll choose to put the first bromo at the 1 and then count around. 1, 2, 3, 4, 5, 6. So my name would be 166 tribromo cyclohex 1,3-diene. So a long mouthful, but again, fairly precise. You should be able to rebuild the molecule from this. Then on the other end, I need to try and identify the longest carbon chain. So again, specifically the one that contains all the double and triple bonds. So I'll start here. 1, 2, 3, 4, 5, 6, 7, 8. This means I have an octene, and specifically then I'm going to have an octadiene. Now let's try and find those locator numbers. So either way I count, I have 1, 2, 3, 4, 5, 6. Confirming 1, 2, 3, 4, 5, 6. So 2,6-diene. Now I have to do the numbering scheme. So here I can go ahead and either put my alkyl substituent at the 3 position or my nitro position at the 2. So we'll choose the nitro position at the 2 and then go ahead and count our way through. So in this case, we have a 1, 2, 3, 4, 5, 6 position for our 2 long carbon chain with a double methyl group. So again, I have the position slightly wrong. It should be a 6, 1-dimethyl 1,1-diethyl methyl, 2 nitro, oct 2,6-diene. So again, starting the name simple, building them out a little bit more complicated as we go. So that brings us to the ends of alkenes and alkynes. Next time, we'll go ahead and take a look at molecules containing arene rings. Until then, take care.